Guys, welcome to properties of cube root of unity, the complex cube roots, which are omega 1 and omega 2, which can be represented as simply omega. Here omega 1 is minus 1 plus I root 3 by 2 and omega 2 is minus 1 minus I root 3 by 2. Now let's start with the most interesting one, that one cube root of unity is equal to the other one. The square of the other omega. And also thus 2 square equals to omega 1, which can also be represented as square, and omega square equals to omega, whichever one you guys prefer. Now here for the first proof we have, oh wait, these two are actually the same, square. So basically we have omega 1 square equals to omega 2, so that means minus 1 taking the right hand side by 2 square. We have, well, we can use a minus b whole square, which is I square root 3 square minus 2 into 1 into I root 3 plus 1 square whole by 4 equals to, well, I square is just minus 1 into this cancel, minus 3 minus 2 I root 3 plus 1. Well, minus 3 plus 1, that's simply minus 2 I root 3 by 4. We can take the 2 common, which will cancel, and this will give 2, which we have minus 1 minus I root 3 by 2, which is equals to omega 2. Then again we can have omega square equals to omega 1. So taking right hand side we have minus 1 minus I root 3 by 2 whole square equals to, well, we can just use the fact that this is equals to minus a plus b square, which is just a plus b square, negative negative positive. So here this is just a plus b whole square, which is 1 plus 2 I root 3 plus I square root 3 square, which is 3 by 4. This is minus 1. Let's do it directly. Minus 1, which becomes minus 3. Minus 3 plus 1 is minus 2. So we have minus 2 plus 2 I root 3 by 4. The 2's cancel. So we have minus 1 plus I root 3 by 2, which is equals to omega 1. Hence, we have proven that the square of one complex cube root of unity is equals to the other one, and vice versa. Now for the second one, another interesting property, that 1 plus omega square equals to 0, or that the cube roots of unity, the sum of cube roots of unity are 0. Well, both complex and the real, all three, because there's only 3 values for cube roots, equals to 0. Now we have 1 plus, well, we know that omega equals to omega square equals to, from the first property, as the square of one omega equals to another, and vice versa. So we can just use minus 1 plus I root 3 by 2 plus minus 1 minus I root 3 by 2 equals to 2 minus 1 plus I root 3 minus 1 minus I root 3 whole by 2. This cancel. We have minus 1 which is 2. 2 minus 2, which is 0, by 2 equals to 0. Hence proof. Now for the third one, the known obvious one, is that omega cube equals to 1. Well, because simply if you cube root and you cube it, this cancels and you just get the number. In this case we have unity 1. So here omega cube can simply be written as omega into omega square. So this also means that the product of the two complex cube roots of unity is equals to 1, or omega into omega square. minus 1 I root 3 by 2 multiplied by minus I root 3 by 2. Now here this is just I root 3 minus 1. This is just minus 1 plus I root 3 minus 1 minus I root 3. So we have a plus b, a minus b, which is equals to a square minus b square. 2 times 2 is 4. A square minus b square, we have minus 1 square minus I root 3 square, which is 1, minus I root square 3 by 4, which is equals to minus 1. So we have minus 3. 1 minus minus 3 by 4. 4 by 4 equals to 1. Hence, we have proved omega cube equals to 1. These are the three main properties of the complex cube roots of unity, or simply the cube roots of unity, because of this.